Welcome everyone, my name is Dr Thobejane. I'm excited to be here. I'll be presenting grade 11 lesson. This is a CAPS lesson on exponents. So on exponents, we really look into the exponents and the SATs, right? I will dwell much on what that those is, right? So the exponents, we can call it the indexes or the power of, right? So where you see indexes, you see exponents, you see power of, it means the same thing, right? And the indexes and exponents and SATs are very important ideas in mathematics, specifically within algebra. Algebra's part of mathematics, right? They are very useful when we comes to reducing expression and solving equations with the different rules or power involved. Now, to able to deal with the various mathematical problems that range from simple ones to the complex cases, it's also really very important to deal with this concept. You are using this concept even in the real life situations. People who are engineers, people who are scientists, various STEM areas, you will find yourself using this even after your matric, going to the university or elsewhere, and even in a workplace. So these concepts are very important for us to understand, hence this particular session. Yeah. So I want to deal with the basics of what are exponents and these SATs. So we want to start from the very elementary so that we then gradually graduate and understand this concept, right? The square root of a number A can be written as you see there, the square root A, or in exponential form, in the sense of saying A to the power to the exponent to the index of 1/2. This is how you can be expressed, right? The square root of a number A can be written as here the square root of A, or in exponential form as A to the power of 1/2, right? Now let's bring it to life. Our A is a 4, right? Means a square root of 4 can be written in this format. You can express it in exponential format in this way. It says 4 to the power of 1/2. When you simplify it further, the square root of 4, you will say 2 to the power of 2. Remember, 4 is equals to the 2 to the power of 2. You write that exponent here. It's still very same exponent here. Then you'll say 2 times 1/2. It means 2 will cancel 2. You remain with 2. The answer is 2 as an example, right? Now, let's go further on this. The cube root of a number B can be written as a cube root of B, or in this exponential form, B to the power of 1/3. B to the power of 1/3. So now example here, we say in the cube root of 27 can be a cube root, as we said, of 27. Now in exponential format, as we said here, you will say 25 1/2. Remember, in our case here, by default there is a 2 here, that's why it was 1/2. But now because there's a 3 here, it will be 1/3. Now if we simplify 27, we know 27 is 3 times 3 times 3. It means it's 3 to the power of 3. This is our cube. Then 3 will cancel 3. We remain with 3. Get it? I think we'll get it with the next one. Now, what we are saying therefore is the nth root of a number c. C can be any number, right? The nth root of a c can be expressed as nth root of c in exponential format is c as a base to the power of 1 over n. What we are saying is, if there is a 5 here and then 9 here, it will be 9 to the power of 1 over 9. I mean 5, sorry, let's start again. If n is 5, if 5 is a root of number 9, as an example, it means here will be 5, here will be 9. How we are going to express it in the exponential form is 9 to the power of 1 over 5. Right? Let's proceed again. Now, this will just now give other examples. In this expression, the cube root, right? The cube root of 64. In this expression, 3 is the order of radical. They call it the radical. This number here, the n number, can be any number, the radical, and 64 is the radicand. Right? Now, we read cube root of 64 as the third root of 64. In the exponential form, the base of expression, the base of expression is called the radicand, and the order, this number is called the radical. Now, this is also just very important for us to remember, right? If you have an equation, nth root of a, as we said in the exponential format, is a to the power of 1 over n, right? And we can raise both sides to the power of k. We have this. So both sides here, you raise to the power of k. You put the k both sides, right? Here, as you can see, here, this simplifies to nk, right, is equals to, the n root of a to the power of k is equals to a to the power of k over n. I hope you get it. Remember, this radical here, every time you remove this root, the root, it will always going to be 1 over it, 1 over n. But because you have a k here, then it's k over n. We'll proceed, but you will get it. But before we can go into the actual solving of the problems, it's very important to understand these basics, right? N root of a particular number, in an exponential, you'll say that number to the power of n. That's very important. Let's proceed. Now, there is also just this important exponential equation, right? You will, by nature, when you practice, you will just know this thing. Some exponential equations have only one solution, while others have more. But it's important to remember this, right? This can be generalized in this way. if x to the power of a over b is equals to c, where c is the constant, 1, 200, whatever, right? Then if a is an odd, remember what is an odd number? 1, 3, 5, 7, and. It means then there is only one solution. It's very important to remember. If you will see that you have a number, you have this base of 2 to the power of 3 over 4, right? What is 3 in this case? If our a is 3, it means the solution that you are going to get, you're going to have one solution. Let's proceed here. If a in this equation here, if a it is even number 2, 4, 6, 10, right? We are going to have two solutions. One will be positive and one will be negative. This is even before you solve anything. If you see such, you will see that if it's an odd number, one solution. If it's an even number, you know that you are going to have two solutions. The one is positive, one is negative. We talked about more on exponents. Let's talk about this SATs. As we said, it's a rational number and it contains a radical. These rules are very, 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 very important for you to understand, right? Product rule and coefficient rule. What it says is that m root of a multiplied by m root of b, it is equals to m root of a times b. But we'll see with an example. Yeah, m root of a times m root of b is equals to m root of a times b, as is expressed here. That is a product rule. Yeah, coefficient rule, meaning this is a division. Here we multiplied product, here we divide. M root of a divided by m root of b is equals to m root of a divided b. Note that these laws only apply to multiplication and division, where a is greater than 0 and b is greater than 0. Right? So it means you cannot have a negative number here and here for these two rules to apply. When we simplify these SATs, we write the numbers as a product of perfect square and other numbers. So, what do, for example, here, right? Square root of 8. Do you have a square root of 8? You need to express it in this. You must simplify it. This SATs, because this is a rational number, right? So you should write it in this format. You should have a way to simplify it, right? What it means is, what is 8? 8 is what? 4 times 2, right? Now we can apply the product root. You can see this number here, right? Square root of this is a product rule, is this side. You can take it back this side. So it means it will be square root of 4 times square root of 2. Yeah? And then we know square root of 4 is what? Is 2. And then the square root of 2 is 2 because you cannot, because it's an irrational number. Right? I hope we understand each other then. Where these 2 come from, right? Is this. Remember, the way this one is written is the same as this here. Right? Then you take it back here. It means square root of 4 dot times square root of 2. We know square root of 4 is 2, and then we remain with this. That's what it means. There are further rules that we need to understand around these sums. Rule number 1, n root of x, as we said, n root of, this is a root, right? Just that we don't have that line here. That's a root. N root of x is equals to 1 over, as we said, 1 over n. We give an example here. Square root of 2 is what? 1 over 2. Because as we said, when you say square, it means we don't write a 2 here, but there is also 2 here. There is a 2 there because it's a square root, square. But if it's 3, we'll write it that there's a 3 here, right? Another one. N root, right? N root of x multiplied by y. This is what? This is a product rule we talked about. It will be n root of x times n root of n root of x. So you multiply y. Actually, apologies, this should be y here. This was just a typo, right? This was just a typo. For example, this is what we say here. Square root of 3 times 2 is equivalent to square root of 3 times square root of 3. Let's start again. Square root of 2 times 3, right, is equals to square root of 2 times square root of 3. This is what it means. Colleagues, now we go to rule number 3. This is a coefficient rule. Talked about it. N root of x divided by y is equivalent or is equals to n square root of x divided by n square root of y. What it means in a practical way is that the cube root, remember the cube root, 3 root, the third root of 5 divided by 3 is equals to the third root of 5 divided by third root of 3. Remember, mathematics is a practical subject. You are not going to theorize these things. You need to write them down, practice, so that they will going to make sense. Right? Now, here it says there is a square root with it, n root of x to the power n. N root of x to the power n is equals to x. Why? Remember, if you simplify it, what is mine? Here, for example, let's go number 1. Let's look at number 1. If there was an n here, x has power n, it means it will be, I think I'll do better next time with this. Let's see, where is the pointers? The pointers. Oh, yes. Yeah, let's try that. Yeah. What we are saying is n root of x, as we said, is equals to x to the power of 1 over n. However, if there is n root of x to the power n, it means it will be x instead of 1 now, because there's a there is an n here, there is an n here, you're going to be n over n. Then n cancel n, hence we are having x only. See, let's do this again here. The square root, the square root of 2 to the power 2. As we said, we don't have the 2, it will be 2 over 2, hence it's only 2, right? The same thing, colleagues, you n to the power root of this, the power n root of x to the power of m is equivalent to this one here. Look at an example. The cube root of 27 to the power of 2 is the same as bringing 2 to inside here to the power, and then, as you know, this 27 times 27, 27 is equal to 3 times 3, right? It's 3 of them. So it means you will take 27, it will be 3 to the power of 3, right? Times 2 over 3. Then 3 will cancel 3. You will remain with 3 over 2. 3 over 2 is equal to what? 9. But just practice this. Simplify it here. Here we just write straight to the answer, but you must simplify it. 27 is equals to 3 to the power of 3. Right? Because of this square, 3 will come and say divide by that number. Hence 3 will cancel 3. You remain with 2. It will be 3 over 2. 3 to the power 2, then it's 9. Similar things here. Use this example here, colleagues. Another important one is, you know, any number to the power of 0 is equals to 1. 100 to the power of 0 is 1. 2 to the power, you know. Similar thing here. If x to the power of m times x to the power of n is equals to x plus, x to the power of n plus n, right? However, the important thing here is only if you do this, only if the base is the same. If it's 2, should be 2 here. If it's 10, it's 10. If it's 2 and 6, that this rule will not apply. The same way with this one of a division, right? You will minus x to the power of m divided by x to the power of n is equals to x to the power of n minus n. Only if the base is the same. Similar thing here, right? And then this here is the same as that, the power. This is the power one. Remember, this is the power rule, colleagues. You will see here. And multiplying, dividing of such, you will find this. To multiply or divide such, you often need to use the distributive properties. If A times B plus C is equals to A, B plus BC. This is simple one. Then we have given an example here. What it means is that if 5 times 3 to the power of 3 plus 9, you just say 5 times 2 is 10. You leave it that way. 5 times 9 is 45. Similar thing here. You will say 5 times 2 to the power of 6. Right? What is a 5 to the power? Square root of 5 times square root of 6. Remember, to the power rule, you will multiply 5 by 6 within the square root. Right? So you will just have to do that. This one times this times this, and this times this one, 6 minus 6 times 18, right? Then you that's how you will simplify. The same way here. Square root of 5 times square root of 5 is 5, right? Because they are removing each other. And then this times this times this, they will cancel each other. Then 3 times minus 3 is 5. That's very important concept. The similar thing here, colleagues, if equation with sides, if they are saying solve for x, what you need to do is, remember this is square root. To remove it, you must say multiply by 2. You write this and then put the brackets, put the 2 here, you apply 2 both sides. There's power of 2 both sides. If you apply power of 2 both sides, that 2 will remove. Remember, square root is 1 over 2. If you put a 2 here, it will be 2 over 2. It cancels each other. Then this side is 8 to the power of 2. Is 64. Then you take 5 to this side. This is how you solve for x. So this is a very important one, and I've seen this even in grade 12. The first question in matric paper 1, question 1. These are type of questions that you should capitalize on. They are very important to understand. Summary: we talked about the power, the coefficient, the raising power to power, right? And this is very important also. Negative exponents can be written as a reciprocal of power with positive exponents. You see here, a to the power of negative x is the same as 1 over a to the power of x. To find the nth root, divide the exponents by that n. Then we said a lot about this one, right? And then you said anything to the power of x is equals to 1 except 0. Anything, right? The basis must always be the same. This is very important, right? Now, I thought we can just quickly do the exercise, and then I've taken this from one of the provinces, grade 11 provinces exams, right? You can see you will apply the product and coefficient rules here, right? Quickly, example, we did the example, this one, 2.1.2. But they're saying, the question is saying, simplify without using calculator. Don't use calculator, colleagues. What you are going to do is, you should apply the product rule. Remember the product rule? 2 times 4 to the power of x plus 2 is the same as this one. You're simplifying this one. It would be 2 to the power of x multiplied by 2 to the power of 2. The same way this side, minus x to the power of 4 to the power of x minus 1 is the same as 4 to the power of x multiplied by 4 to the power of minus 3. Then what you do is, this 4, so you can pull, you see 4 is here and here, then when you pull it, when you take it outside, you remain with 2 times, what is the 4 times 4? It's 16, right? 16 times 2 is 34. Now, you take it outside, is here, you remain with what? 4 to the power of 3. What did we say? This rule is this rule. I hope I'm not going to confuse you. Is this rule. We apply this rule. It means 1 to the power of 4. 1 over 4 to the power of 3. And then 4 to the power of 3 is 64. Then you simplify it like that. So the point I'm just trying to say is, those rules are very important for you to understand. You can quickly do this one as a last example, but I will urge you to go and work on those other examples, right? 5 to the power of x plus 1 plus 5 to the power of x is equals to 150. Our rule, right? 5 to the power of x dot 5 to the power of 1, this 1 here, plus 5 to the power of x is equals to 150. Therefore, what we are saying therefore is here you take as a common factor. You take 5x from here, you remain with 5 to the power of 1, which is this, plus if you take this 5 to the power of x, you are going to remain with 1 here, right? Therefore, it means if you say 5 to the power of 1 is what? Is 5 plus 1, the number is 6. Therefore, we are saying 6 divided by 150 is equals to what? 25. But 25 is equivalent to 5 to the power of 2. If you say 25 times 25 is the power of 2. Therefore, because the base are the same, is 5 and 5, therefore x is equals to 2. This is what I wanted us to talk about, the exponents. And then this is a fundamental to your career in STEM areas. You need to understand this so that you're going to be civil engineers of this world, computer scientists, and many things. That being said, colleagues, I would really like to thank you to give me this opportunity to talk to you. As I said, my name is Dr. Thobejane from UNISA ICT, and we're looking forward to engage you in an upcoming session on this critical subject of mathematics, and we'd like to wish you the best of luck.